This one is a pretty challenging problem. Wall 8 meters high stands 4 meters away from a building. So you're seeing this this picture here. There's the 8 meters. There's the 4. What is the length of the shortest ladder that will lean over the wall and touch the building? So visualize this ladder moving, closer in toward the wall or farther away. And so what is the length of the shortest ladder that will lean over the wall and touch the building? They tell you to use as the variable the angle the ladder makes to the ground. They didn't actually have to tell you that, but they did. So we'll use it. So this is your angle, theta. So the ladder is broken up into two parts, A and B. The angle theta is also up here, so that makes this be 4. So we're trying to optimize this time. Is the length of the ladder, and in this case we want to make it a minimum. Okay, so our constraint is that we have the 4 meters away from the building and the 8 meter lengths. So it's a little different than some of the other problems. So the length of the ladder is sine, so we go for sine theta is equal to 8 over A, okay, which means that A is going to be 8 sine theta, 8 over sine theta. Then looking at the small triangle, cosine of theta is the 4 over the hypotenuse B, which makes B equal to 4 over cosine theta. So then the length of the total ladder is the sum of those two. There's your length equation, length of the ladder. Then you differentiate, and you get this. Set equal to 0 to find the level points to see where you're going to have a minimum. Do some trig algebra, work it all out, end up with the tangent of the angle is cube root of 2. So that theta is the arctangent of cube root of 2. So then you make a separate picture. Here's theta. Its tangent is supposed to be cube root of 2. So cube root of 2 over 1. Then the hypotenuse is going to have to be the square root of the cube root of 2 squared, which is cube root of 4, plus 1 squared, which is 1. That's pretty tricky. The only reason why you'd want to do that is that you're really trying to get the exact answer in these problems, not just a decimal, although a decimal is good also to verify. So the length of the ladder, depending on theta, is the original expression for the length. So what is sine theta? Sine theta on the diagram, there's your diagram. Sine theta is opposite over hypotenuse. Opposite over hypotenuse. And similarly, 4 over cosine theta is 4 over cosine theta. Cosine theta is adjacent over hypotenuse. That's this, adjacent over hypotenuse. Now we go to the next page to simplify this out. So here's your quantities we left off with on the previous page. So the length of the ladder, just cleaning that up algebra wise. Maybe it could be cleaned up more, but we're going to keep it like this. So that's the exact value, this right here. And if you stick that in the calculator, as we do over here, this is the way it has to be written. You gotta be really careful with all those because there's nested cube roots inside square roots. So this is the decimal number for the length of the ladder. Okay, then to verify that out, I graphed L of theta. Of course you do. You put in with x's. You don't put in theta. So in the calculator it was x and L of x. But you have to be in radian mode. So the mode has to be in radians or this graph won't look good. So that's what it looks good when you put x as the argument. And here's your 0.89 and your height, which is the length of the ladder, is 16.64, like that, 65. So that verifies out with the second calc minimum that you really do have the exact correct expression for your length of the ladder. That verifies that this horrible looking quantity is actually correct. Now, let's say you didn't want to go through all that horrible algebra of getting to this this number here. I mean, you do have to get to that, and you really should try to do that, and that will clean up all your algebra skills, by the way. But just to verify, you could graph the derivative, which is done over here. Graph the derivative and see where it crosses 0, and do a second calc 0. And you can see that it comes out 0.8999, the same exact x's was over here. So it's the same angle answer. Then you would plug that in to L. So you'd be doing L of the 0.899. You'd put the whole accuracy in there, 8990835, just to put it all in there, and evaluate that, and you'll get the 16.64, well, approximately rounded on to 65 meters. So you use your exact methods. Challenge yourself to try to get these algebra answers exact. This is the exact version. And then do your technology skills to verify everything using the calculator.